Hi guys, welcome to the channel Learn Concepts with Nikhil. Discover, learn, and grow. In this particular lecture, we will be learning about introduction to the joints, like the concepts of joints, and from the next lecture, we will be implementing directly on the MySQL server, MySQL workbench. But now we will be understanding the concept of joints, and like we will be understanding the concepts of joints and how many joints are there, what is their purpose करके. Like we'll also get, like we'll also know about the purpose of the joints and different types of joints. So joints, 1 minute guys, I'll, yeah, joints. So basically, like data is not stored in one table, it is stored in multiple tables in a database, right? Right, like as we know, like uh, data is not stored in a big table, like large table, but the large table is broken down into smaller chunks, smaller tables, and data is stored in those smaller chunks and smaller tables, so that like we can fetch the data from each and every table as per our needs and requirements. Joins are used to retrieve or fetch the data present in multiple tables of the database. So if you want to know the, like, if there is student ID, let's suppose like there are two types of tables. One is order, one is order table, and other is product table. Let's assume this as one is order table and other is product table. In order table, there is order ID as well as order ID as well as order name. But in product table, there is product name, product ID, product category, and all. But I want to know the product name of the order. Like I want to know the product name of the order number one. So that with the help of joins, we can fetch the data of the product category or product name with the help of joins. We can fetch the data of product category. We just have to know that order ID. Like there should be one common column between uh, there should be one common column between order ID and product ID, so that we can fetch the data easily. So like we can fetch the data from multiple tables with the help of joins. So joins are used for that purpose. If we store the data in all the data in one table, we will be getting three types of alamone, not anomaly. Sorry guys, anomaly. Yeah, we will be getting three types of anomaly. One is insertion anomaly, second is update anomaly, third is deletion anomaly. So I will explain you about this. First is insertion anomaly. Like it will be have like lot of duplicate data will be there in insertion anomaly. For example, let's consider this is the big table, right? Actually, this is a small table, but for example, I am saying like, for example, I am showing this example. Suppose there is a new course added, CSC 103. So CSC 103 is the course added. Uh, and the student number, student ID 101 is enrolling in CSC 103 course ID. What happens here is like already we have the details of 101 allies data. Already we have the information of student number 101. Again, if we enter student number 101, again we have to enter allies and like we have to enter like for example, student name is there, student ID, student phone number is also there. Let's assume student phone number is also there. One sorry, 123 145 14154 123 213. So इधर क्या होगा कि like in order to enroll, like in order to enter a student ID, we have to enter all the duplicate data, right? Already we have the alias data here. Like in the first column only, first record only, we have the alias data. But it got repeated here again. Why? Because he enrolled in the another course. It will be repeating again here. Why? Because he will be enrolling in the third course too. So that we want only the student ID. but we are getting the duplicate data of name as well as phone number. So in order to tackle this insertion anomaly, we are using joins so that we can segregate the data, like the big data present in the large table, into the smaller tables, and we can tackle the problem easily. So with the help of joins, we can tackle insertion anomaly. Next is update anomaly. Update anomaly is like, for student number 101, Alice's name is printed wrongly. Alice's name is typed wrongly. Let's assume it's not Alice, it's Alice B. So, in order to update this Alice B, we have to update in every record where Alice is present. I have to keep Alice here, as well as I have to change the Alice name here also. So I have to update on each and every recorder, so that like it will be taking lot of time, right? Lot of time consume hoga, lot of yeah, like we have to do update for each and every record in which the particular data is present. So in order to again tackle this problem, we will be using joins. And next is delete alimony. For example, I don't want this record, right? Alaska record, I don't want this Alaska record. Let's assume not Alice. Let's go with Charlie. I don't want this record. Because he got something job as job, so he left the course and he went to the job. So I want to delete that Charlie ka record. But if we delete the Charlie's recorder, we will be losing the entire information of Charlie, as well as we will be losing the important information of the Charlie, important information of that record. For example, if I delete this one, we will be losing the important record like phone number. Also, we will be using his student ID. Why? Because for the next students, we can allot the student ID based upon the existing students, right? So if we delete this record now, we will be losing entire relevant information of the data. So that it will be hard for us to give the student ID to the next new coming student. So easily, again, in order to tackle this problem, deletion alimony is used, so that uh, instead of this entire big data, we can create a students table as well as course table, right? So in students table, we want the course ID of Alice. We want to know the course instructor of Alice. We can directly fetch the course instructor, who is the course instructor of Alice, with the help of joins. So in order to tackle all these alimony, we will be using joints. So now there are 7 types of joints. One is inner join. Second one is left outer join. Third one is right outer join. Fourth one is full outer join. Full outer join. Next self natural cross. So these are the 7 types of joints present in SQL. But these four are very important in the perspective of the corporate. Why? Because we will be using inner or left join most frequently. Sometimes left join आया तो right join is very easy for us, and full outer join there is a even we will be using full outer join too, but we will be using these three rarely. Natural join is also somewhat related to inner join, but there is a limitation ki all the columns should be same in both the all the columns should be same in both the tables. So but it is similar to inner join only. So we will focus less on a natural join. We'll focus less on natural join. Sorry. We'll focus less on natural join. Cross join be utna like they will be not asking many questions on cross join, and it is also not important. And self join is used rarely, but we will be discussing about these four types of joints: inner join, left outer join, right outer join, and full outer join. So we are using MySQL, right? In other platforms like MS SQL, PostgreSQL will be supporting full outer join, but MySQL does not support full outer join concept. It does not have the full outer join concept. But how we can tackle this problem? We will be like seeing that in yeah, we will be seeing the when we are doing the implementation. So I will be giving the small trailer of all these joints. So first one is inner join, right? Suppose if there are two tables, right? The common data we have learned in our childhood or in our school, right? Intersection is nothing but the common data. Yeah. Inner join is nothing but the intersection. I guess it is right only. Intersection is nothing but the common data. So all the common data between the two tables is nothing but inner join, right? So simple. Common data between two tables. Only the common data. There is no data. It will not, inner data will not be giving any other data related to left table or right table. It will be giving only the common data which is present in left table as well as in right table. That is inner joint. Left outer joint is quite intuitively you can understand. It is quite intuitive. So left outer joint is something like all the records or all the rows from the left table as well as common data, right? We will not get any data related to right table. We will not get any data related to right table. We will be getting only the data of left table as well as common data. Next one is right joiner. Right join is nothing but a opposite to left joiner. We will be getting all the data from right joiner as well as we will be getting the common data, right? So this is right joiner. Full outer join. Sorry, 1 minute, guys. Oh, excuse me, 1 minute, guys. I'll be rubbing this all. So full outer join is nothing but we will be getting data from all the tables. For example, yeah, there are two tables present. So full outer join is nothing but we will be getting that data from all the tables, along with the common data. So sorry, like uh, like to repeat again, inner data is nothing but only the common data from the tables. There will be like we will be not getting any data related to left table or right table. We will be getting only the common data of the both the tables. Left outer join is nothing but like we will be getting the data from left table as well as common table, like common data. Right outer join is nothing but completely opposite to left table. That is, we will be getting data from right table and common data. And full outer join is nothing but we will be getting the data from both the tables. So this is about joins, guys. And remember one thing: if you are focusing on joints now, there should be at least one column that should be matching two tables. Like two tables में एक column तो common होना चाहिए. At least there should be one common column between two tables. So this is all about introduction to joints, guys. From the next lecture, next video, we will be we will be implementing joins practically on my SQL workbench. So yeah, thank you, guys.